a Bohr's postulate. So some books they're calling that as 4, some books they're calling 5. So anyway, like you can just this one. So what he had a background. What happened? He took about the Planck's radiation, energy is quantized. Energy is quantized. So like that happened, the revolving electron, its energy is quantized with telling. So first what he said, like a electrons revolve in circular orbits. Then, so if it revolves in circular orbit, then what should happen? It should radiate like a, who will provide centripetal force? If it revolves in circular orbit, who should provide the centripetal force? Same electrostatic force. Then it will be accelerating. Then accelerating charge particle should give out radiation. Accelerating charge particle should give out the radiation. Then what is said that one? I'll write in order. Electron revolves in circular orbit. Then it said that the angular momentum I'll put in proper order. Huh? So some let me write here. Angular momentum of revolving electron is equal to integral multiples of h by 2 pi. So what is angular momentum? So that will write L nh by 2 pi, where n equal to 1, 2, 3, 4, 5. And what is the angular momentum of revolving particle? MVR. So this is about the angular momentum. Next is telling that there are some, so sir, here also the electron is revolving, centripetal force there, acceleration there. Why it will not radiate? It's telling that they are stationary orbits, means the electrons, when they revolve at a certain specific distance from the nucleus, they will not radiate. But according to classical physics, if an electron accelerates, it must radiate. And what is the electron? Electron is a particle. The Bohr, what happened, he was not knowing that like something wave. I'm making things clear. Later on, what happened, we are going to treat that particle electron as a wave. So what Bohr suggested is like the angular momentum is quantized and the energy is quantized. Energy of electron is quantized. Next again, what is telling? The electrons revolve only in special orbits called as stationary orbits. Only in special orbits called as stationary orbits, due to which it will not radiate. See, once it will not radiate means what happened? The kinetic energy of electron is constant. Kinetic energy of electron constant, then the distance of the electron from the nucleus constant. So the stability of atom, yes, he was able to explain. Then, from as the energy of electron is quantized, the next question comes: what about the hydrogen spectrum? Yes, he was able to explain. When an electron, so this is the no. What about the how we was able to explain the hydrogen spectrum? If this is the electron n equal to 1, quantized states n equal to 3. So when the electron jumps from higher orbit to lower orbit to higher orbit, when it jumps, when it makes a transition, then it absorbs a photon, is telling. When it makes a transition from lower orbit to higher orbit, then it makes a transition. Then when this called like excitation. So what actually happens in excitation? Electron what will jump from lower to higher orbit. So when it makes a transition, then what it absorbs a photon. Then when it undergoes de-excitation. So what do you mean by de-excitation? I think I'll draw the diagram. No. So when it makes a transition from lower state to higher state, then it will give out energy in the form of a photon. So this particular photon is corresponds for the hydrogen spectrum, and he was able to explain the hydrogen spectrum with the help of this. So this is called like a excitation. What do you mean by excitation? When atom absorbs a photon, the electron will jump from low to higher state. What do you mean by de-excitation? When electron jumps from higher to lower orbit, then what happens? It will give out that energy in the form of photon here. And this particular photon corresponds for that hydrogen spectrum. And he was able to explain hydrogen spectrum. See, once stability is achieved, and he was able to explain the hydrogen spectrum, finish over. So then this was very hard to digest. What made that particular electron to not to emit radiation? Because you can't blame Maxwell's fundamental law. Electrodynamics is a fundamental law. Maxwell's equations are fundamental. Accelerating charge particles should give out radiation. So what made this electron not to radiate? The Bohr, he just proposed that this is quantized, because he had the idea of this particular thing. He had the idea of Planck's radiation. Energy is quantized. So energy of electron is also quantized. Then later on, when he solved it, even the R. So the electron cannot be available at all points. Only at some specific locations, it will be located from the nucleus. That is called as stationary orbits. Stationary doesn't mean that electron will be at rest. Electron will be moving. V1. Here, how much of speed in second orbit? V2. They'll be revolving in the stationary orbit, and as long as it's there in that orbit, it will not radiate. So I think it, and if the electron is not in that stationary orbit, it is going to radiate. So everyone was puzzled, like, say, how come electron, though it's exciting, will not radiate? You just say that it's a stationary orbit. As long as the electron is at some specific distance from the nucleus, it will not radiate. So what are the specific distance? We call that as R1. The distance of stationary orbits, that he derived equation from here. He derived. So nothing but that you can look at radius of the stationary orbits here. As long as the electron is at a distance R1, R2, R3, it will not radiate. And if it were anywhere between R1, R2, it will radiate. And he proposed that these are the only some specific states. The electron cannot be at all distances. Only at some specific distance from the nucleus, it can be located. Therefore, it's like a space is quantized. So later on, the electrons revolve. So what he proposed, like a space is quantized. He didn't say it. We are just, even the space is also quantized. Means the electron cannot be accommodated at all distance from the nucleus, only at some specific locations. So that he proposed that okay, space is quantized here. Now it will be really very difficult for us to, even as a student or a teacher, no, we find very difficult. Sir, why your laws of electrodynamics failed here? The simplest reason, the electron is not behaving like a particle, it is behaving like a wave. The Bohr was not having this idea. Niels Bohr is a complete name. He didn't have idea of the dual nature of matter. Dual nature of light was there. Dual nature of matter, what happened when it came 1924. He didn't have idea. In fact, what happened? It was due to dual nature of matter only the things are like this here. The electron is not being particle. If it were particle, it will radiate. Are you getting, all of you? I'm just putting in a very simplified way. In books, what happened? They didn't explain like that. They just left the Bohr's atomic model, because the reason Bohr, when his postulates came, and they printed almost after you can say like a 11 years. After 11 years, what happened? The matter waves came. Matter waves come. The dual nature of matter. So even if you see the books, what we have, no, so no book will say that the electron was being like the wave, but it is left to teacher to explain, to convince students that one. Because when Bohr was explaining, there was no idea of the matter wave. So to that clearly, what when the Bohr, what when if I say it behaves like a wave, then you feel okay. Bohr thought it's a matter wave. No, Bohr never thought it's a matter. It's like a wave. The electron was a particle only according to the Bohr. According to the Bohr, the electron was a particle. He just proposed because. So what he said, since energy is quantized, so here energy of electron is quantized, and as long as they're in the stationary orbit, it will not radiate. Finish over. And he was able to, he said that, see, what all I am suggesting, it is satisfying hydrogen spectrum. Then what is your problem? Why don't you accept? That people started accepting this one. So once what happened, the matter waves came, de Broglie hypothesis. Then almost in 1920, like a matter waves were concluded practically. Then they came back. Oh, what Bohr's side was that electron was not a particle, it's a wave. So the moment you say electron is a wave, no question of electromagnetic radiation. Finish over. Nothing to do with Maxwell equation, and you should not ask any question also. Finish over. So the revolving electron, what when it will behave like the wave. Sir, what about nucleus? Nucleus is a particle. Even present quantum model, the nucleus is treated like a particle, but the revolving electrons are treated like a wave, or they're treated like a quanta. Finish over. No question of any electrodynamics here. Getting the idea, no? Like this is what we should conclude. Since we know almost all the ideas, now we are in 21st century, it behaves like a wave. So for your convenient, I'll write it. Electron behaves as a so no radiation from it. So no radiation from it, though it accelerates. Bohr was just, it's like a Bohr defended himself by what? By hydrogen spectrum. See, like what all I propose, I'm explaining hydrogen spectrum. Please don't trouble me. And the energy is quantized, the space is quantized. So that was the first, you can say, the basic fundamentals for quantum mechanics. Nothing but what happened? This Bohr's atomic model is what? The fundamental model for the quantum mechanics. So therefore, they didn't discard it. Even anybody wants to learn atomic structure, you must start with the Bohr's atomic model only. Then you have to climb up higher level. So how do that de-excitation, when electron jumps from higher to lower state, called as de-excitation. When electron absorbs, or when atom absorbs the photon required for excitation, that's required to jump from low to higher state, is called like a excitation. So like that, he was able to explain the hydrogen spectrum and also the stability, all particular thing. Okay, let's calculate now. Expression for the radius of stationary orbits, the speed and the energy level diagram. He proposed further the energy level diagram. With the help of energy level diagram, he was able to cleanly explain the hydrogen spectrum. What are the drawbacks of Bohr's atomic model? The Bohr's atomic model failed to explain what, like the Zeeman effect, the shell concepts, subshells. So this further, the Bohr only what meant? So he called them K. The subshells, what happened, he was unable to explain. Because as the technology got improved, we are able to see the subshells. So from where the subshells, and this is applicable only for hydrogen-like atoms. 2 electrons, the Bohr's atomic model fails. So this Bohr's atomic model is applicable only for hydrogen and hydrogen-like atoms. It failed to explain the subshells and also the Zeeman effect. Almost some around 9 defects are there. So as the technology got improved, the Bohr's atomic model failed to explain the most of the modern things. So therefore, it was just kept for a fundamental studying that one. So next what happened became Sommerfeld model, vector model, quantum models, like that. From almost around 15 atomic structures are there. Different. I think in chemistry you have come across few. Different atomic structures, they just got improved with the time. So our syllabus is now both atomic model only, and will conclude here only. We don't go beyond this. We have to stop it at both atomic model only. So what is the next thing? So we have to bring expression for the radius of the nth Bohr orbit. So the electron revolves with a speed. So this is the distance. So who will provide required centripetal force? The electrostatic attractive force will provide required centripetal force. So we'll write it here. Fe is equal to mv square r. And what is Fe? Z e square by 4 pi epsilon naught r square. This is equation 1. Then other side, what we have is angular momentum is quantized. I think you just imagine it's it's not that something on pen paper. See, that's what I'm suggesting you like. What happened in our still in our India, what happened? We do think that science and technology is on pen and paper. That's why we are unable to do anything breakthroughs in the science and technology. Even if you ask any student here, why you want to do Olympiad, why you want to become IIT, it's I want to do research. It's a wrong thing. You should not reply. You should say that I want to explore science and technology. I will do many lab practical things. I'll analyze, I'll observe. Then new observations I will notice. This is called like this is the main idea. Almost you can see the most of the basic science you have come across. None of the thing what happened, none of the scientists what happened were like started with pen paper. They started with practical observation. The practical observations, they brought that on paper in the form of mathematics. Then what happened, they tried some relationship, and there the theory and ideas came, the inventions came. But in India, what will happen? People, you are taught in wrong way that you should first analyze on paper, think it. Not possible. How do you can make an imagine of a nature in your mind when very nature is available in front of you? That's why the research, why we are so much backward. If you compare in terms of research, no, we are 150 years backward compared with Western countries. Even IISc, you take it, or Tata Institute of Fundamental Research, because there everything is practical. They just do experiment. They do some stupidity, you can say. They just type, why can't be like this? Why can't in a lab? When they say some sort of new thing, then what happens? Immediately that point, they'll repeat that. They'll gather the data. Then they come onto the paper. Why this? I'm seeing the different nature. Then they'll start exploring mathematically. They'll relate laws. Then the new thing will come. I think the very procedure itself is lost here. So why I'm telling this to some of you are interested in Olympiads. That one. And the students will prepare for Olympiad almost without any much background. But if you go for the Western school education, he is able to see alpha scattering in his schools itself in 8th, 9th, 10th, 11th, 12th. What happened? In schools, what happened? They were exposed to do almost of the basic fundamental photoelectric effect. As they do in schools only, they're made to do that one. When they're doing experiment, what happened? When they make so many changes, no, new things will be observed. And they were trained to make observation. They're trained to make changes, and they're trained to make observations. So from that, they'll get a skill and they'll get a confidence. And when they want to do anything new, no, that practical knowledge will be, the background will be there. But here, I think things are totally different here. That's why we are unable to produce that breaking things in science and technology. This is the only reason. Even if you go to the most of the research labs, suppose say I was doing electromagnetic waves. I am a BTech engineer. Okay, that one. So what I used to do, my duty is to study that electromagnetic radiation. And during my time, if I design any antenna, I think now you can see in the mobile, no, very thin antenna. At that time, we were just designing such a very thin antennas in 1996, 97, that one. Such thin antennas where we can put on planes, everything. That was project we were doing. And from Bangalore, what happened, I had to go to Cochin if I want to do in a lab, because I want to study that particular radiation phenomena. In the entire South India, there was only in a Cochin. So from Bangalore, I should go to Cochin. In the Cochin, what happened again, a slot, like a, for every 6 months, we'll get a one slot. I think my MTech, what happened, my MS in engineering was only like a 4 sems. So my entire project, what happened, I'll get only 4 slots, that too one day. How it is possible within 4 days I'll make so many observations? And that too I was given just one day, in that one day 3 hours. Within 12 hours, how do I can study? Even nowadays also situations are like that only. If you want to design any antenna and if you want to study radiation, your South India should go to Cochin. And what is the cost of that particular lab, microwave lab? It was at that time, it was costing around 20 lakhs. Can't we invest now 20 lakhs? 20 lakhs we can invest, but the science, what happened, the government is not investing in the research equipments. And the persons, what happened, without doing any practical thing, what you do on paper. Now what happened, I spent most of the time on paper. And finally when I went into the lab, no, things were totally different. So what I assumed on paper and what I did in lab was different. Again I came back, then again I started. So like that, what happened, if I spend some more time in lab, no, then on my equipment I would have got better knowledge. But finally what happened, I completed my electromagnetic master's degree in electromagnetic wave designing of antennas without much practical knowledge. Then same thing happened when I went to defense lab. There also same thing. When you say defense lab, means yes, they should be there. No, again the defense lab, that one. So for every 5 defense labs, okay, one practical thing what you can do it. Again, the movement of there, this one. So these are the things. So we are not investing in what, like the practical thing. Good example, our college only. We don't invest in lab. No, to set up physics lab, how much you need? 5 lakhs is enough. Huh? And you can do almost 800 experiments, which will give at most clarity about the physics what you are learning. But we are not doing. Schools also now they stopped it. IITs also they didn't invest. IISs also stopped it. So almost you go anywhere in India. So there's nothing called like a practical analysis here. Everything is on paper. So then gone. No? So that's why what happened, the most of the well allied persons, they for research, no, they go abroad. They go to MITs or Oxford, everything. The reason is the practical equipment. It's not that we are not having that particular research thing in blood. The facilities are not there. And past 20 years, you are really trained in a wrong way. Just on paper, on paper, on paper. I think you are nowhere in the picture now. So, sir, how to do that one? Yes, you can buy. You can buy one prism, you can buy one laser beam, you can buy concave mirror. It will cost you nowadays 10, 15, 20 rupees. Unless you don't do that, not possible. This one, even IITs also, they failed to impart that practical observation. So that's why the research, again, breakthroughs from IIT is also very poor. Anything for nation from IIT is nothing, no, till now. You look at the agriculture, the Indian farmers are facing so many problems day to day. And the IITs can really come with a very good equipments, no, to assist farmers. Nothing. So any reason? Because no practical knowledge. See, you need practical knowledge. Without practical knowledge, you cannot do anything for society. So these are the whole set. That one. Please do, because the cycle is such that only you have to bring changes from on your own, because the system will not permit you. Because as a teacher now, so shall I teach you in lab? I think the weekend syllabus will not be covered and exams will not get marks, and UK sir will bombard you people that why marks not getting. And your parents will question UK sir will question you. Finish or no? So the very purpose of learning things has got destroyed here. So like we are in a wrong cycle. You means, shall I call myself teacher? No, I'm just so like a news reader. Some questions are there, for that answer I'm reading, I'm going. So no longer I'm teaching physics, and no longer you're learning physics. It has become everything like a dumping. Teacher comes, questions gives, read questions, and for that you'll propose some answer and it'll go. Everything has become diluted here. So you can't set right things on your own, because as the system will not permit. I'm trying now. You have internet in your hand, in front of you. Now you're sitting at a the entire world is in front of you now. You type anything, what happen, it's videos, it's research material. Of course, time will not permit. At least in the revision, what happen, you can do that. What you are learning, just see the videos. Don't watch again the some physics lecturers from so and so teacher. The teacher again will same thing will on board. He'll put it. Do watch practical things. As alpha scattering, as practically video is available. Watch it. Such things you have to watch, because I've seen students like, are you using internet? Ah, sir, I'm watching your video 5-6 times to understand. That is not use of internet. No? Sir, I'm watching some Fiji, one professor, one good video, explained his things that I'm watching. Again, the same thing. What is there in the book, the teacher will omit in front of you on the screen. That omitting is what taking place here. No? I'm not putting any content my own. No? What is there in the book, I'm writing it here. This is not called like a, of course you're learning, but will not benefit you much for your research purpose, this way of learning. Because unless you don't hold prism, concave mirror, convex mirror, the photoelectric effect experiment, what happens if you don't do practically, there's no way thing. So I think you do photoelectric effect. Do you think that within 1 hour you can do that? Minimum 3 days you need it. Huh? So what all you gain knowledge, no? You try to do photoelectric experiment, try to verify that graph. Definitely I can say that you have to spend minimum 3 days. Because you don't know anything, how to handle that equipment's connection. So please set right things, at least not, I think in IITs you get a platform where you can bring changes in your way of learning. May not be here, get into IITs, but in IITs definitely will not, IIT will not help you, but there the environment, what happened there, the resources what happened can help you to bring changes on your own. Again, the institution will not help you, but you can bring changes. Okay, let's get into mathematics now. So there are two equations to unknown. Let's solve for V and R and we'll get the expression. These are Bohr's postulates. No? So what is that? Angular momentum is integral multiples nh by 2 pi. After solving this, so I'll end up the, shall I directly write the derivations? So the expression for the velocity of, first we'll go for radius, that one. Radius of the nth Bohr orbit is given by n square h square epsilon naught pi mass of electron, it is e square z. So this everything, some constants are there. We'll rearrange this, everything will become 0.53 n square charge of nucleus in terms of Armstrong. So this is called like a naught, or called a naught n square z Armstrong. What is a naught? A naught is called, or I think books they called Bohr's orbit. I think for example, better to remember this. Scientist name, capital letter we have to write. Yeah. Radius of the nth Bohr orbit is given by this particular formula. Put n equal to 1. What are the permitted orbits? And z equal to 1, hydrogen atom. Let this be hydrogen atom. So what are the permitted orbits? So where do you can locate electron? Only at distances a0, 4a0, 16a0, 25a0. What do you mean by that? Space is quantized. Huh? Nobody accepted. Means space is quantized means, what does it mean? Means like I'll enter into one room. Then I'm permitted only to sit at benches as if the rules of the classroom, what when they'll put a condition that you should sit only on the bench. Then shall I say that your spacing is quantized? So the Bohr, what happened? He has to explain. No, he just like say, let's assume that a classroom. So then what happened? Below everything, what is there till knee level. So only what happened? The student can sit on bench. Tell me like what is the permitted level there? Only on the benches he can accommodate, and in one bench only one student can sit. Next student what happened at a distance 4a0. Next, only in specific benches what happened? In a classroom, see he has to defend himself, no, because nobody was able to understand what he was telling. So he was proposing that one. Say this is the, so let's assume a classroom, and only the rule of the classroom, what it says, you can sit only on the bench. and the benches are at specific distance. Shall I say space is quantized? The same thing happens for the like a matter at microscopic level. And since we are made up of atoms, so why don't it's applicable for us? In my house, I can only sit at sofa. I should not sit at any other point. I think nothing, no. So at microscopic world, what happened? The alignment of the particles, what happened? They do obey the quantization. They do obey the quantization. Similarly, what will happen? If you, again, the Einstein further proposed, like not only this, if you look at the total planetary system, universes, the planets also are not at specific, cannot be at all points, they're at specific points. Later on now, I think the modern quantum mechanics is telling that even the macroscopic objects also follow this space quantization. The total universe is what happened is in one specific order. The matter is specific order, they're telling. So that particular quantization at our level, we are unable to realize. At microscopic S and at macroscopic, the total universes. According to science, only one universe is there, but latest research telling there are billions of universes are there. Even the universes follow that quantization is what they're telling. So this for the electron is not permitted at all the distances A0, 4A0, 16A0, 25A0. So space is quantized. I'll write that statement. See, the only thing is the background. What is the background? Because the Bohr is inspired by what? Planck's radiation law. Rutherford was inspired by what? Maxwell's equation. So based on that inspiration, the background theories what they proposed there. So spaces, books they didn't cite, but if you look at the most of the modern books, no, the Western books open, that they're putting this statement: space is quantized here. For the electron, it is like so. Time being, you can put like this. And then what about the speed of the electrons? So speed of the electrons, again, the expression for that when we solve it, E square 2 epsilon naught hc. Okay, so wait. When I solve it, z e square 2 epsilon naught nh. This what will happen in a very simplified form. It is written as and velocity of electron in the Bohr's orbit is called as c by 37. C by 37 z by n. I think this will be much easier form, no, than the first one, the second one. So how Rn is proportional to n square and Vn is proportional to 1 by n. Similar to like a planetary, as the orbit radius of the orbit decreases, orbital speed decreases. The same thing happens here. Okay, agree this. So this is expression for the speed as well as the radius of the nth Bohr orbit here. So I think the formulas I suggest you have to remember this for exams. Widely it is used here. Okay, let's go for the energy, that one. I suggest you students to simplify this. I directtly wrote equation 192. You can simplify. Solve 192, substitute V from 2 in 1 and solve for R and R. You'll get expression of this kind. Similarly, let's go for energy. In what all forms this electron possesses energy? No, there's the interaction potential and also the kinetic energy. So the E is equal to U plus K. Interaction potential energy should be equal to minus ZE square 4 pi epsilon naught m v square by 2. Okay, solving for this expression for energy, we'll get it. Okay, let's substitute all now. We know value of R is n square h square epsilon naught pi m e square z. V square will be z e square 2 epsilon naught NH. Or else in the book what when they derive separately expression for U, separately they derived expression for kinetic energy. They brought relationship because that is very, I think I'll follow the book. Huh? Let me follow the book. I'll follow the book. Why again? You'll get confused, no? Let's derive expression for first kinetic energy. mv square by 2. Z square 2 epsilon naught NH whole square. So this will be Z m e to power of 4. 2 is there, here 2 square, 8 will come, 8 epsilon naught square n square h square. Z square also will be there, mz expression for potential energy. Potential energy is given by minus Z e square by 4 pi epsilon naught Rn. Tomorrow we'll bring that matter waves in the atomic structure. When we draw that energy spectrum, no? I'll introduce that wave nature of electron. So time being, first we'll focus on these things. So this will be n square h square epsilon naught pi m e z square. I think everything here 4 will be there. You look at all the quantities m. Rn here z will not be there. Huh? Let go for this one. So this will be m z square e to power of 4 pi get cancels, so epsilon naught square n square s square. So negative sign will be there. Look at that potential energy and kinetic energy. Any relationship between them can we bring? And we'll calculate the total energy now. The total energy will be sum of these two. So m z square e to power of 4 8 epsilon naught square n square s square. Now what we get total energy will be negative. Any relationship can be right between the energies. Similar to in gravitation, can recollect here. So mod of u is equal to, shall I say, k is equal to mod of u by 2 plus mod of u by 2. Agree this? You look at the energy divided by 2 mod of that, or sorry, it should be like this. Huh? Is that okay? I think this is something related to what? Conservation of energy principle. Similarly, what can I apply conservation of mechanical energy? Yes, you can apply it. So like that, how the kinetic energy, potential energy, and the total energy of the atom, they're related by this equation. We are the Bohr what happened here, we are not bothered about the spin of electron. Even the electron will have a spin. We don't know anything now. We are exactly in 1912 and we don't know anything spin of electron or any other things. Don't compare with modern atomic structure. Just go back to almost, you can say like a 108 years, you have to go back totally. So there's a relationship between kinetic energy and that one. So this energy now, let me put in still more simplified form. So this energy of electron. So finally, when you substitute all the quantities, this we can also write it as En is equal to minus RHC Z square by n square, where R is called as a Rydberg constant. And the value of that is 1.097 into 10 to the power of 7 per meter. And what is Rydberg constant? The Rydberg constant here we are expressing, and the different Rydberg constants will come. That I'll discuss in the numericals later. H cube into C. So this is a value of the Rydberg. So like this we can express in terms of Rydberg, or if I substitute the values, so like this what he was able to express now the energy of electron revolving in an nth Bohr orbit. So these are very popular what we are using. So this is the final our thing which you, if you remember well and very good. What is strictly mass of electron? So in numericals what we just do take help of this one. If they ask something in terms of Rydberg, take help of minus RSC z square by n square. If they ask you some sort of like in electron volt, you are going to take help of this one.